So yesterday we started with a new topic that is called as your multicast. Okay. Within the multicast, we have seen like a basic introduction I have given you. Apart from that, we have taken down the IGMP, in which there were three versions: version 1, version 2, and version 3. What were the issues in the version 1 that we moved ahead with 2 and then we moved ahead with 3? So we have discussed all of these things, and lately then also we discussed regarding your multicast routing, in which at the end uh, I told you that ultimately for at the layer 2 between the last hop router and or the switch towards users or the host machines, we are running a protocol called as IGMP. Whereas between the routers, we are using a protocol that is called as your PIM. Okay. So now, talking about more into this and mainly about the PIM, the main goal of the router is to route the packets, right? That we all know. The main goal of the router is to route the packets. So whenever it receives an IP packet, it has to look first of all at the destination address. That is a basic scenario. Then it's gonna check to the routing table and gonna figure out that what is the next hop where I need to forward this IP packet. So we use the routing protocol to learn the different network and to fill in the routing table. That is the use of the routing protocols which we are using, like EIGRP, like your OSPF and the other protocols as well. Okay. This complete concept applies on to your unicast traffic. That if I have one router and I want to reach out, let's suppose, to a destination. So I do have a router which is being available. That particular router is having the IP, let's say 192.168.1.1, and somewhere I need to reach out towards a destination which is 1.1.1.1. Okay. So the router will tell that, okay, I know that how I need to reach 1.1.1.1, which is my last hop destination. But that completely applies on to their unicast. Okay. But what about the multicast traffic? What to say over here? Okay. So now let's see that how the multicast traffic will come into the picture. For the multicast routing protocols. Okay. So let's say that I do have a video server over here. Again, this is a server. The server is having any kind of IP. Just a second. The server is having any kind of IP. Okay. Let's say 192.168.1.100, for example. Okay. And this is being reaching towards router. There is a router, router R10, and then towards your router R2, for example, and then you have the destination address, which is 1.1.1.1. Okay. As for the multicast traffic, so whenever this kind, so if the traffic is being flowing from the server, the source address will be this. What will be the destination address? What do you say? The destination address will be, let's say that there are certain users who want to watch my stream or something, who want to watch that live stream or the cricket match or the football match. So the destination address will always be the multicast address. For example, 239.1.1.1. The routing table is a basic unicast routing table. There is no information about any kind of multicast address in there. Our router will have no idea that where to forward its multicast traffic, where he needs to forward this particular traffic which is related to the multicast. Then for that purpose, when that issue came into the picture, we got to know certain multicast routing protocols. Okay. There are two types of multicast routing protocols. One is called as dense mode and another one is called as sparse mode. Okay. One is your dense mode. To route the multicast traffic, we need to use the multicast routing protocol, and there are two types of those particular protocols, which are dense mode and sparse mode. Okay. First of all, very first thing, dense mode is not being supported in Nexus. And no one actually uses the dense mode because it's not scalable. Okay. Dense mode routing protocol are used for such networks where most of the subnet in the network should be receiving the multicast address. Okay. It is being used where almost all of the host machines want to watch that particular cricket match. Whosoever the end host users are there inside that complete network, they all or maximum wants to watch that match, then only you use the dense mode. Because whenever the router receives the multicast traffic, it will flood. So dense mode is all about the flooding. Dense mode is all about the flooding. Whenever a router being received with the multicast traffic, it will flood it on all of the interfaces except that particular interface where it received that multicast traffic. Okay. The one on which he received the packet, he'll not do it. He'll not again send the packet. But other than that, on all the interfaces, he's gonna route that particular multicast traffic. That is the usage of the dense mode. Okay. So even if there are certain hosts that don't want to receive that stream, but still they will be receiving. A multicast router can easily tell its neighbor router that it doesn't want to receive the multicast traffic anymore because I don't have it. So let's say like this is a server from which the traffic is being initiating. There are certain routers like this in the network which are being flowing, for example, and later on some more routers, and then there is a switch, and then there are multiple host machines. Okay. A multicast router can tell to its neighbor that this, let's suppose this router is there. It can tell to its neighbor, to this router, that I don't want this particular traffic. Reason being, I don't have any hosts which are directly connected to my interface or something. So where should I send? So I don't want that particular multicast traffic. They can easily tell that. Okay. But flooding is being taking place over here. Okay. Now let's say that I'll give you an example over here where I do have a server. The server has sent the traffic to router R1. The server has sent the traffic to router R2, and then there is router R3 also. Okay. Kind of, this is an example. My source is let's say 1.1.1.1. My destination is a multicast address, mcast address, for example, 239.1.1.1. The traffic will go like this. Okay. Then this router gonna flood that particular traffic. It will flood over here as well. It will flood over here as well. Okay. Now this router R2 is saying that I don't need this traffic. I don't have any end host machine to which or whosoever wants to watch the match. So kindly don't send me this. And my router R3 is also saying that I also don't want this traffic because I don't have any kind of user which is being available to watch this traffic. Okay. So my R1 over here has actually flooded the traffic to all of the interfaces rather than this one, because from here he received the traffic. So other than this, he has flooded the traffic to all other interfaces. And on the other hand, router R2 and R3, nobody is interested in that multicast traffic. So they gonna send a message to that. Okay. That particular message is called as prune message. That message is being called as prune message. They will send a prune message to signal the R1 that they no longer needed or they don't need to forward any kind of multicast traffic. Okay. Now this particular dense mode is being used by PIM also, is being used by MOSPF also, multicast OSPF, and is being used by another protocols like DVM-RP also. Distance vector multicasting routing protocol. We are talking of all over here about PIM. So PIM does support both the dense mode as well as well as the sparse mode. But the thing is, your Nexus devices as per the data center does not support the dense mode. They only do support the sparse mode. So PIM is the most popular routing protocol, which we're going to discuss over here. Okay. No one uses the DVM-RP and the multicast USPF. Now, within that, there is another issue that is called as your RPF, also known as reverse path forwarding. Now, what is this? Mainly, what happens is your multicast traffic is completely vulnerable to the loops, to the routing loops. Okay. So just like in your Ether channel, whenever you talk about the port channel or something, why you create the port channel? Because it mitigates all of the looping issues which are coming because of the spanning tree protocol. Multicast traffic is, or the routing is also vulnerable to the routing loops. So there is one very simple loop prevention mechanism that the router will never forward the multicast packet onto the interface where they receive the packet on. For that, there is an additional check which is being defined, and that particular check is nothing but your RPF, reverse path forwarding. So let's understand that I do have a server over here, again 1.1.1.1. This server is being sending away to the traffic with respect to router R1. There is a router R2, and then there is a router R3 which is being connected like this. Okay. My source, my video server has sent the multicast traffic, correct? This multicast traffic is being sent over here, flooding the multicast traffic. Again, this traffic will send over here. Again, this traffic will be sending over here. Okay. Now a loop got generated. Our R1, router R1, who receives the multicast traffic, that he has flooded on all of the interfaces except the one from which he received on. This particular interface will never be flooded. Okay. So R1 has sent to R3 also, R1, and then R3 has sent to R2, and R2 again sent back to R1. Now this is a loop which is being happening. And we can actually prevent this particular loop by implementing your RPF. So whenever a router receives the multicast traffic on an interface, it looks at the source IP address. It's gonna look at the source IP address. So let's suppose my R1 got the multicast traffic. R1 did check what is the source IP 1.1.1.1. When the multicast packet is being received on the interface, that's gonna match the information from the unicast routing table. It's gonna pass that RPF check and we're gonna accept that particular packet. And when the RPF check got failed, we're gonna drop that packet. How come? Okay. So let's say that I do have R3 over here. I do have R3 over here, router R3. My R1 has actually flooded the traffic, multicast traffic to both R2 and as well as R3, and R2 it also flooded to the R3. Now R3 gonna perform an RPF check for the multicast packet. It's gonna check that what is the source address. The source address is what? 1.1.1.1. This is your source IP. And then where it gonna check this? Inside the unicast routing table. So let's say that it find an OSPF entry for the complete network 1.1.1.0 network /24. That is pointing towards R1. The packet that it receives from the R1 will pass the check since we have received it on this particular interface. So it will pass the check that, okay, I got the reverse path forwarding. I know that this packet has been coming from 1.1.1.0. I'm never going to again send this particular packet back to the same interface. Simple as that. Okay. But when it is sending this packet towards R2, that information he doesn't have. So that particular packet will now be dropped because RPF checked has been completely failed. This is what you have inside the dense mode for which your RPF is coming in the picture for the mitigation. But most of the time your dense mode is not being used. The main which we're gonna talk about is your sparse mode. Okay, also known as PIM sparse mode, protocol independent multicast. Dense mode is very inefficient. Reason being, flooding is being happening over there. Because of the flooding only, it is very inefficient. And you only use the dense mode when you have very few routers inside your network. Okay. Otherwise, you'll be wasting a lot of bandwidth and the resources on your routers. Whereas your sparse mode is far more efficient in that particular case. Because the sparse mode only forward the multicast traffic when another router requests for it. Your sparse mode, again I'm telling, because it will be related later on, it only forward the multicast traffic when another router requests for it. Completely opposite to the dense mode. And the flooding will be heavily reduced as well over in this particular case. Okay. Now, in this, requesting the multicast traffic, it sounds good. It's a good concept over here. But it comes up with a problem. What is the problem? That inside the complete network which I have, how I'll get to know that where I need to send that request? With the dense mode, the problem was that whether you want to look at the traffic or you don't want to look at the traffic, you will be receiving it. But in the sparse mode, the main problem comes over here is that how I'm gonna tell that whether I want to receive this traffic or not, whether I want to, how it gonna request it. Okay. Because in the sparse mode, you have no idea where the multicast traffic should come from. In order to fix this issue, in order to fix this particular issue, so that I can know that from where my traffic has to come or to whom I need to request that particular traffic. The question over here is to whom I should be requesting the traffic. The router is asking this question. Requesting for the multicast traffic because I don't know that who gonna send me the traffic, right? There can be so many routers like this. You understand? You imagine in this particular way. How this router will get to know that I need to request him, then the request will go somehow and I'll get the traffic. To fix this issue, sparse mode creates or you configure basically a special router over here. That special router is nothing but one of the router between the network. Okay, and that particular router is called as RP, also known as rendezvous point. Okay, also known as rendezvous point. All multicast traffic is being forwarded to the rendezvous point. And whenever now other routers want to receive it, they will just need to find their way towards the RP. That means if this is a picture of the topology, if this is a network, then all the router only needs to know, let's say this is the RP over here, which I have created. For that, there is a configuration, of course. I'll tell you that particular configuration later into the picture. But I'm going to make this particular router over here, R1, as a rendezvous point. Now, all these routers, on these routers, I'm going to tell, okay, that whenever you want the traffic to be received or you want to request the traffic, you kindly find a way to reach out to the rendezvous point. Simple as that. No rocket science. All the routers will be configured in such a way that they will be told that whenever you want to request the multicast traffic, you need to reach your rendezvous point. He will be the one who will be forwarding you the traffic. Simple as that. Now the question comes at that how you gonna configure that? For that, there are two types of configuration, static also and dynamic also. We're gonna look at the static one as well. That how on other routers, I'm gonna configure and I'm gonna tell that okay, your rendezvous point is actually R1. You have to reach over there in order to get the traffic. in order to get the multicast traffic, because this router is, let's say, connected with any of the server. So now this router knows the information that how I need to send this information to all other routers, and they will be requesting only to me. So in general, okay, there is no rocket science. In general, the meaning of the rendezvous point means you might have heard or you might have saw spaceships, right? Spaceship means not the alien spaceships, only the Indian Earth spaceships, basically. Okay. All the space shuttle, whenever they are going into the space, okay, they they are traveling, and then they have to travel for a longer distance. You might have seen that there are certain junction points which are being created. In movies also we have seen that there are junction point or the stations. These are called as junctions or the stations. On those particular station, they do the fueling. They do the complete fueling. And then they cover that complete long hours of journey inside the space. That fueling stations are called as rendezvous point. This, in a normal basic terminology, also being called as meeting point. Let's say 5 friends are there. Okay. Anderson is there, Arvind is there, Malav is there, Jobair is there as well, and Robin is there. And we are all telling that today we'll go on to a bike ride. And while going on to a bike ride, you are saying that because he is living in the north area, I am living in the southern area of the city, might be he living in the eastern area. Like that, all the people are living in the different areas in the city. So we're gonna make a junction point that this is my rendezvous point over here, whether it's a tea stall or a coffee shop or a cafe, we're gonna meet it over here. And then from here, we're gonna start our journey. So it's a meeting point. This is the basic meaning of rendezvous point, just to make you understand. Now let's understand how we gonna configure or how we gonna see that what rendezvous point actually we gonna do over here. Okay. So let's say I'll carry forward the same topology which I had. That this is my server over here. The server is being connected to one of the router R1. And then I do have another router. I do have over here another router, and this router is also being connected to certain hosts. This router also being connected to certain host machines. And I declared that my R1 is the rendezvous point. Okay. From where it is receiving the traffic? It is receiving the traffic directly from the video server. But at the moment, nobody is being interested in that traffic. Right now, you understand in that way that at the moment, nobody is interested in that traffic. So my rendezvous point R1 will never forward that particular traffic to anyone. It will never forward it. Okay. Now, tell me one thing. When, let's say, router R2 over here and this is router R3. Okay. Arvind, you don't tell if you know the answer. Okay. How my R2 gonna request that particular traffic? My R2 and router R3 are requesting that multicast traffic from another router. Why is that case they're gonna make the request? What do you think? Why they gonna make the request? Like someone might have told them, right? That you need to make a request in order to receive the multicast traffic. Who gonna tell them? Any idea? Anderson, Jobir, Robin, Tuan, Yusuf. Ah, correct. Join in the group. For that, what is the protocol which we are using? IGMP. Okay. Robin sir, this is clear. First of all, my host will request that we are setting up a group over here. We require the traffic on 239.1.1.1. A membership query, just now membership report or the membership query I told you. So the membership query will be going from the host machine towards the R2 asking for, I need the traffic on this particular address, kindly send me. At that particular moment, my router R2 will get to know that, okay, you want the traffic. For that, you are already running the IGMP protocol in this case. And now my R2 got to know that, okay, they are requesting the traffic. So now that request will be forwarded to another router. That particular request will be forwarded to another router. That means if I just little bit, give me 1 second. Let me create it in a good way. Okay. And then chalo. So one more I'll create over here. Connection. 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 Chalo. Then we add a switch also. So a quick drawing just to explain certain things, and I'm gonna add my layer. Now understand. Who is this? This is the source. This is the source server. Who is this? Router R1, which I'm creating as a RP. This is router R2. This is router R3. This is my switch. And these are H1, H2, H3. Host 1, host 2, host 3, host 4, host 5, host 6. Okay. And there is one more. Let's say I'm creating over here host 7. This is also connected to the switch. It's just that I'm creating a long line. Okay. Now, understand over here what's going to happen. I'm giving a complete explanation over here. First of all, the video server will send that particular video stream or the multicast traffic to whom? To router R1. R1 is the rendezvous point over here in this particular network. Okay. Now, for let's say this host number 7, which I have it over here, he wants send multicast traffic. So what he gonna send? Any idea, anyone? What he gonna send? What is that message which is being called? Arvind, Anderson, what do you say? Membership info? That is called as absolutely correct. IGMP join message. Okay. So my host will send a IGMP join message request towards the router R3. There will be a membership query which will be going on. In that case, my host will send a IGMP join message that, hi, I want to join this particular group 239.1.1.1 in order to watch the tonight football match. Okay. Yesterday we had cricket. Today we're going to have football, for example. Now, my router R3 has received that particular request. R3 received the IGMP join message. And now, what is the protocol which is being running over here? Can anyone tell me? Protocol PIM is being running, layer 3, protocol independent multicast. Now over here, you guys need to understand one thing, that underlay is already there. Okay. I'm hoping that underlay is already built it up. R1 has the complete address information about its neighbor R2. R1 has complete information about its neighbor R3. In the complete routing, your underlay OSPF or EIGRP is completed. We are using now the PIM protocol on top of that, protocol independent multicast. So from this router R3, there will be a request which will be going towards my router R1, and that request is called as PIM join on the address 239.1.1.1. The request which is being going from router R3 towards the router R1. R3 receives the IGMP join message, and then it gonna send that particular request to R1. But at that time, your protocol will get changed from IGMP to PIM. Now, because it is requesting in order to start sending the multicast traffic. So R3 has sent a PIM join message. We'll talk about PIM over here later. There are certain things which are being left over here. Okay. Now what gonna happen in this case? Obviously, R1 gonna start sending or forwarding that multicast traffic towards router R3. It's gonna say that, okay, here you go with the traffic, you can just forward it out. At that particular moment, what will be the source IP? What will be the source IP? First, let's suppose the source IP over here is 1.1.1.1. So source IP will become 1.1.1.1, basically the server IP. And what will be the destination IP, guys? MCAST. Let's say 239.1.1.1. This particular packet has been going from router R1 towards R3. R1 to R3. That this is the source IP and this is the destination IP. Now, and later on, this packet will be forwarded towards your router, host H7 also, towards the host machine. Our host will now be able to receive that multicast traffic. Now, in this case, what happened? Good. We didn't wasted any kind of resources also. We didn't wasted any bandwidth in order to send the unwanted multicast traffic towards router R2, because in router R2 and hosts which are present, H1 and H2 are actually, let's say, Arvind, Anderson, and Mala are present, all three, and they don't want to right now watch that particular match. So they never initiated that request. And when they are never initiating it, R2 will never send the packet, request packet. So my R1 doesn't have to send the traffic towards R2. So this is completely gone, which is a good thing. Which is actually a good thing. So whenever you are using the sparse mode, all the routers need to know that what is the IP address of the RP. Then only they can send that particular request inside your sparse mode. Then only they can send the PIM join message towards RP. For that, my R3, there is a manual configuration which is being required. On R2 also, there is a manual configuration which is being required. And I'm going to tell that your R1 IP is, for example, to 1.1.1.10. I'm configuring this IP on both R2 and R3, saying that your RP address is this. Kindly reach out to him whenever you want the traffic. Whenever you want that particular traffic to be coming. Okay. This much is clear. Robin sir, clear? Tuan? Yusuf? Jubair sir? Wonderful. Yes. Could you explain? Yeah, BIDR will come into the picture, Anderson. Just certain, give me some time, it will come up. Okay. Now, what else? So what we understood till now, that inside your PIM sparse mode, until and unless someone gonna request it, we're not gonna flood that particular traffic to that router. Okay. Now, let's understand certain more things over here. So let's say that my R3 again received with the, okay. Or for example, that when my H7, my host, is being sending the IGMP join message. When the host is being sending the IGMP join message, or let's say, for example, I'll remove this all and let's again start from the scratch. Okay. That join message is also called as membership report. Okay. First of all, in somewhere in certain blogs or the books, you're gonna receive IGMP join message. Somewhere you're gonna read that. That is called as your IGMP membership report. Okay. So today we got to know that there is a server who is streaming the traffic onto the multicast address, which is 239.1.1.1, for example. Over here, I do have the router R2 and I do have the router R3, and R3 is the one who wants to receive that particular traffic. For that, why R3 want to receive the traffic? Because there is a host machine who has actually sent the IGMP membership report towards R3 that I want this particular traffic, kindly send me. Okay. Now, how this R3 is supposed to know that the video server is being located at the address which is 1.1.1.1. This is the destination address. This is my source address, source IP of the server. How my R3 will come to know that my server is located at 1.1.1.1 or my traffic is being located at 1.1.1.1. For that, we have created the rendezvous point, correct? So my router R1 over here is the one rendezvous point in that particular network. Each router that receives the multicast traffic from a source will forward it to the rendezvous point only. Remember that. It is fixed. My server will only send the traffic towards the RP. No other router. Each router want to receive the multicast traffic will have to go towards the RP. Like R3 and R2, if want the traffic, they have to reach towards my router R1, which is the RP. So it's a meeting point for all the multicast traffic which is being there. Okay. Now, R1, let's talk about rendezvous point over here. Now, R1 receives the traffic from the video server, and my video server obviously has forwarded that to the RP. R3 wants to receive that traffic from R1. Okay. But there is one more problem over here. How my router R3 will get to know that where I need to go to find the RP? Maybe there can be one more router like this, right? This also can be a network. Or again, this also can be a network. There can be so many routers which can be added on top of that within that network. How my router R3 will get to know that I want to reach out to the RP in order to gain that particular traffic? For that, there are a couple of different options to configure. First is the manual configuration that you're going to configure the IP address of the router R1 on each of the router. Okay. For that, there are certain protocols. There are some protocols that can automatically discover the RP in the network. That is your another way. First of all is the static way where you're gonna manually configure on each of the router that who is your RP address. And second is your dynamic way, which we'll talk about it later into the segment. Okay. Now, let's take this particular thing further ahead. So, our video server is forwarding the multicast traffic to the router R1. Clear? Which is being received by R1 on this particular interface. Since we are using the PIM and that too inside the sparse mode, the router will have to forward the multicast traffic towards the RP. The server will have to forward the packet towards the RP. Instead of forwarding everything, now understand over here, our server is forwarding the multicast traffic on its interface, which is being received by router R1. Okay, so my RP has received with the traffic. Instead of forwarding everything, R1 will only send the first packet. R1 will only send the first packet over here. So let's say, for example, what I'm trying to say over here is, it's not necessary that R1 has to be directly connected to the server. Okay. My R1 can be connected to router R4 also over here, and this R4 is connected to the server. So your initial traffic of that cricket match or that football match, this can go like this also. The ultimate point over here is that I have created R1 as a rendezvous point, so he has to get the traffic. And every other router into the picture will request to the RP only for the traffic. Okay. So let's say my R4 has received the traffic and R4 has to forward that particular traffic to the rendezvous point. In that case, what R4 will do is, R4 will not completely send the traffic. Instead of forwarding everything, my router R4 over here will only send the first multicast packet. He will not send the complete stream in one shot. He will only send the first multicast packet. And that particular multicast packet, I'm writing it down so that you can easily remember and you can understand, that packet is encapsulated in a PIM register message. That traffic is being encapsulated in a PIM register message. R1 will only send the first multicast packet, and that particular packet is being completely encapsulated in a PIM register message, and that is being forwarded towards my router R. Once this router RP receives the PIM register message, now there are two options. Okay, there are two options. Understand over here. This RP, okay, will it be having all the information that who are the routers who are trying to request me for the traffic? Yes or no? My RP will have that particular information, that what routers inside the network are asking me for the traffic or requesting for the multicast traffic. What do you say? Why no? Why not? If any of the PIM join request is being sending from R3 or from coming from R2, he will have that particular information, right? That there are certain routers who are requesting for the traffic. Does it make sense? IGMP has happened and PIM join request has been sent towards R1. R1 has that information. Yes? Right? Now, okay, Robin sir? Yeah. So it should be having that particular information whenever someone is being asking. Now, the point which I want to draw over here is that I thought, acha, IGMP happened. IGMP happened. You think in that way. Okay. Now, the point I want to make it over here, when nobody is being interested in that multicast traffic, then simply that router RP, okay, RP, when nobody is being interested, at that point, my RP will reject the PIM register message. My RP will reject the PIM register message. And when there is at least one receiver, then only the RP gonna accept. RP gonna accept that particular message. There has to be at least one receiver for that. Then only your PIM register message will be accepted. So for now, I'm hoping, and let's understand that there are no such users. This is my RP, router R2, router R3. Let's connect like router R4 and do like this. Remove this particular link. Okay, router R1. Now, what I want to say over here is, for example, just now, trust the process that there is no user who actually want that particular traffic. So my RP in that case will send a response. Why is sending the response? Because initially he got an encapsulated packet. That particular packet at the point number 1 is called as PIM register packet. Okay. At second point, when I got to know that, when RP got to know that there is no such router who actually wants to accept the traffic, he will send a message that is called as PIM register stop message. When he know that nobody is interested in my traffic right now, so my RP will send the packet towards router R4 saying that PIM register stop. I don't want this message right now. And this particular message will inform the R1 router R4 to stop forwarding any multicast traffic as of now. Understand? So smart they are. Okay. This is my server. instead of sending the complete stream in one shot, they are only sending the register message, so that my RP can tell me a reply that, okay, whether I have any kind of user who are demanding this stream or not. If they are not demanding the stream, he will directly send the PIM register stop message. Simple as that. No rocket science. So now in that case, my R1 will stop forwarding any my router R4 will stop forwarding any multicast traffic. But the question comes over here is timing. Timing means how long I should wait. How long my router R4 has to remain silent by not sending the traffic again. By default, when we receive the PIM register stop message, my router R4 will start a timer. What timer is called as? That is called as suppression timer. He will start a suppression timer. As soon as he received the message number 2 over here, I'm writing in this way so that you can understand. As soon as he received the message number 2, PIM register stop message, he gonna start a suppression timer. And the by default timer is 60 seconds. And not after the timer has expired, no. But when the timer is almost expired, my router R4 will again send another traffic toward RP. At the time when the suppression timer is almost about to get expired, at that particular moment, my R4 router will send another packet towards the router RP. What that packet will be? That packet again will be a PIM register message. But in this, there is a twist. This PIM register message does not carry the encapsulated multicast packet. Remember that. The second time, at the third time, after the suppression timer, again, I'm writing it over here, again, PIM register message, packet will go, but without encapsulation. There will be no encapsulated multicast packet which will be binded in that particular request. It is simply a request just to make sure and just to ask to the RP that, are you okay now? If anyone is interested right now, tell me. Okay. 60 seconds earlier, I sent you a packet. You responded me again that I don't want the packet right now. So again, I'm sending you the request, but this time I'm not sending you the packet again. Encapsulated packet again. You just kindly let me know if you are ready, and then I'll start streaming. I'll sending the stream. Simple as that. This particular packet, which is without any kind of encapsulation, this is called as PIM register null packet. This is called as null packet because there is no such packet which is being going in that case. And now we are still not having any kind of receivers. So again, the RP will send another PIM register stop message and this game will go on. And when at the time we do have the receivers which are actually available, the RP will not send the PIM register stop message. The RP will not send the PIM register stop message. And at that time, my R4 will start sending the multicast traffic towards the router RP. This is how the router RP gonna get that particular traffic. Now you know that what happens whenever a source starts sending the multicast traffic without any kind of receiver. Okay. Now let's see that what gonna happen in the case when actually the IGMP is also running and actually there is a PIM request which has gone for this traffic. So what I'll do is I'll clear this also. This is my server connected to a router R1, for example. This is being connected to router R4 this time. And this router R4 is actually the rendezvous point also. This R4 is being connected to, for example, router R2. This R2 is connected to router R3. Okay. And then to this R3, there is a system which is being connected. This is my end host. Okay. And there are certain more routers in the picture. You can understand in that way. This is a network topology which I'm drawing. Now, what's gonna happen when there is actually a receiver who wants to accept that particular traffic? End host will send a, what he gonna send? He gonna send a IGMP. Number one, IGMP membership report. That hi, I want to have the traffic on this address 239.1.1.1. Okay. Receive the IGMP membership report. Now, this router will think that, okay, now I want to send the PIM join request towards the RP. Who is the RP? Router R4 over here. Okay. My router R3 will send a PIM join message. My router R2 again will forward the PIM join message towards router R4. Okay. Because my router R2 actually received that particular traffic from router R3, that I am receiving this PIM join request from my downstream router, and now I want to forward this or send this to the RP again. This is how your RP gonna know that, okay, now I need to send that particular traffic. Okay. Now, what else? To summarize this process, your PIM sparse routers will send a PIM join message. Whosoever the routers are there, they will all send the PIM join message. And the last routers, actually, which is R3 in our case, has received the IGMP. Then only he got to know that I need to initiate a PIM message. Now understand over here. When the RP receives the PIM join message, it will start forwarding the multicast traffic. The concept of joining the RP, okay, this complete concept of joining the RP from here to here, this concept is called as RPT, route path tree, also known as shared distribution tree. Okay. Where your RP is the root of the tree, which decides that where to forward the multicast traffic. Because each multicast group might have different sources and the receivers, so we might have the different RPDs in our network. What I want to tell is, this is also a router. It can be connected to multiple hosts. This is also a router. It can also be connected to multiple hosts. This is also a router. It can be connected to a switch where there can be multiple hosts. Okay, so the path will be getting changed as per the request. The path will be getting changed. That's the reason it is called as root path tree or shared distribution tree, where my RP is the root of the tree and it's gonna decide that where I need to send this particular traffic. Reason being, there can be so many multicast group. Let's say over here the multicast group is 228.0.0.1. Over here the multicast address is 239.0.0.1. Over here it is 239.1.1.1. There can be multiple addresses who can request. So there will be different RPDs which will be carrying forward or being taken care of. Okay. Now, what else? Let's see certain more things inside that. Okay. When my router R3 has received the multicast traffic through the RP, when he received the multicast traffic through the RP, it also learned the source address of this traffic. And what is the source address? Now, easily this R3 can decide that it wants to use the SPT instead of the RPT to receive the traffic or not. He wants to use the SPT or not, or he wants to route the basically use the RPT or not. He can easily decide that. SPT stands for source path tree. Okay. There are two trees which are getting created over here. One is called as root path tree. One is called as source path tree, where we know that who is the source who is actually sending the traffic. When my router R3 has received the multicast traffic through the RP, it has also learned the source address of this traffic. Now my R3 can decide that it wants to use the source path tree instead of the root path tree to receive the traffic. And when it wants this, it will send a PIM join message towards the source. And the other routers will start sending up the traffic directly. Okay. When the traffic, understand, when the traffic has arrived from R4 to R3, he got to know that who is the source of that particular traffic. Acha, who is the source of the traffic? Anyone? Server, right? The source of the traffic is the server. At that particular moment, what gonna happen is he gonna choose the methodology that is called as SPT, source path tree. Now, in this, what gonna happen? He can actually decide, that where I need to go in order to get the traffic done. So what he gonna do is this R3, he directly he gonna send the PIM join message to the best path from where he can reach to the server, to the source, rather than sending to the RP. When RP is there, that is called as root path tree, RPT. When SPT is there, source path tree, that means he's not gonna send the message again to R4 asking for the traffic. Rather than that, he will find the best path because he know that the source address is 1.1.1.1. He got to know. So he's directly sending the PIM join message towards the server that okay, kindly tell me the traffic. I'll handle the traffic. He gonna reach out to the server directly. And what he gonna send to the RP in that particular case? He gonna send that prune message that I don't want this traffic as of now. That is called as your source path tree. And you will see this particular output also. When we're going to do the lab in the multicasting, there will be distribution trees which will be created at the time. Once the multicast is up. At that time, you will see either SG or you're going to see star comma G. Okay. This S comma G is source and G stand for multicast group address. Star, which is wildcard entry. And G over here is again multicast group address. Now, the point is, what is star over here? In SG, you have the source path tree where you know the source, that who is the source who is sending up the traffic. When you see star G, what do you mean by star over here? Any idea, guys? Any source, that is called as any source multicast. Okay, so star comma G, you will see the output in the lab also. I'll show you. Star, any source multicast. Can you right now give any practical example for any source multicast if anyone understand? Any application? Robin, Tuan, Jobair, Yusuf. Acha, chalo. I'll give you the best example over here. Right now, Malav is over here. Okay. You all guys are muted. You cannot speak it. Okay. You have nothing, no rights over there. I am the one who is speaking. I am sending the traffic to you. This is called as where you know the source also, where I know have the destination also. Zoom, very good. Best example as of now. Live example you're gonna get. Over here, I am also sending up the message. Malav is being sending. Anderson is being sending. Arvind is being sending. Zobair is being sending. Okay. Robin is being sending. Tuan is being sending. We all are talking to each other. We all are talking to each other. Traffic can go from anywhere to anywhere. Okay. And all are having a particular multicast address. But what is the source? No one. That is called as your any source multicast. Or any cast also. Sometimes it's called as any cast or any source multicast. Where you have the abbreviation *, you don't know about the source. You only know about the group address. So group address is nothing but the Zoom meeting where we are landing up and we are talking. But source is anyone. Anyone can talk over here. That is called as your any source multicast. Clear? So this is your sparse mode. Now, within the sparse mode, there are so many multiple things as well which are there. Okay. One is called as auto RP. Multicast PIM sparse mode requires a rendezvous point or the meeting point in the network for the multicast traffic that we have already learned and we understood that. First of all is that we manually go ahead and configure the RP IP address on all the routers. Let's say if there are multiple routers in the picture, okay, on all the routers, I'm going to tell that your RP address is, for example, 172.16.1.1, and whenever you want the traffic for the multicast, you're going to request to your RP. So this IP I'll configure on all the routers manually. On all the routers manually. Okay. But this thing is not scalable at a bigger end of the network. For small network, there is no problem. Where there are 5 to 10 routers, obviously I can go ahead and configure the IP. Okay. Acha, what is the best interface to select at the time when you are creating the IP? Creating the RP. Best recommendation, best interface out of the switch or the router. Always choose the loopback interface. Very good, Anderson. Okay. It is recommended that you always create a loopback interface as a rendezvous point. Reason being, your physical interface by any means can get down. Okay. There is no such case that your loopback interface will get down until and unless your complete device is down. So that is the best recommendation for choosing up or configuring an RP. And we'll see that as per the last scenarios also, don't worry. So for smaller networks, configuring the RP address manually is not a big deal. You can easily do that particular job, but on a larger multicast network, it's not a good idea. So for that, because it takes time for the configuration to take part into, okay. And also whenever there are so many routers, errors might come easily. Errors might come easily. For that, you have two options. One is called as auto RP. So basically, I'm telling up dynamically setting up the rendezvous pointer. One is auto RP, second is called as BSR. This is called as bootstrap router. To configure the RP address dynamically, there are two ways, auto RP and bootstrap router. Okay. Now, first of all, let's understand all about your auto RP. That what is it? Okay. Auto RP is a Cisco proprietary protocol. First thing. Proprietary. It's a Cisco proprietary protocol. Other than that, there are two things inside the auto RP. So let's first quickly discuss about auto RP. Point number one, it's a Cisco's protocol. Second, there are two different roles which are being defined inside that. What are the two roles which are being defined? Those rules are, one is your candidate RP and second is your mapping agent. Now, what are these? I'll try my level best to make you understand in a very simpler terminology. The candidate RP is that particular router that gonna announce itself that it wants to become the RP for the network. Okay. It is just like there is a classroom of 100 students and one student stood up and he says that, okay, I want to become the monitor of the class. I want to become the supreme of the class and want to manage the complete class over here. So that is nothing but the candidate RP. Candidate RP chooses himself as a candidate that he wants to become the RP. he gonna announce itself that he wants to become the RP on the network, and it does by sending up certain messages. What kind of messages? It does by sending up RP announcement messages, RP announcement packets. How he gonna tell that I want to become the RP over here? He gonna send the RP announcement packet. Okay, to whom? To whatever the multicast address is. Okay, and there is a particular address for that. It's not like any address. There is a dedicated, just like in the OSPF, I asked you yesterday, what is the dedicated address which is being taken down? 224.0.0.5 and 6, you have given the answers over there, right? For the OSPF. Similarly, there are some for the EIGRP. Similarly, the candidate RP gonna send the RP announcement packet on a particular address. That particular address is called as 224.0.1.39. And that you can see sometimes inside the Wireshark captures or in the different outputs also logs when the logs are generated. So RP announcement packets are being sent to this multicast address. Second is your mapping agent. Mapping agent is the one or is the router actually who gonna listen to the RP announcement packet. They're gonna listen to the RP announcement packet from the RP candidates and gonna make a list of all the possible RPs. Okay. So now, giving this example again, do you really think that in the crowd of 100 students, only one guy will stood up for the monitor section? There can be multiple people, right? Whenever the election is being happening inside the democratic country, there are so many candidates over there who are coming up, raising their hands and telling that, okay, we want to become the, what I would say, president of this particular country or minister of this department. Similarly, there can be multiple routers who gonna elect themselves as a candidate that we want to become the rendezvous point. And they will all send the announcement packet. Mapping agent is that router who gonna listen to those announcement packet. That, okay, I got the information from you also. I got the information from you also. You also want to become the candidate. You also want to become the RP. Over here, one more is there. He also want to become the RP. This is my mapping agent. I'm the one who gonna listen to all of you. And I'm gonna make a list that, okay, Malav is there who wants to become the RP. Arvind is there who wants to become the RP. And let's say Jober is there who wants to become the RP. And over here, the mapping agent is Anderson, who is listening and who is making up a table that, okay, entry for Malav, Arvind and Jober. And these are the one who want to become the RP and I'm the one to making up the list for that. And then my mapping agent, it will elect an RP. So it's completely depend upon the Anderson that he gonna elect one RP and he gonna inform the rest of the network with the RP mapping packet. Those are called as RP mapping packets. Okay. He gonna give that assurance to everyone that RP has been successfully selected. And those RP mapping packets are being sent to a multicast address that is also specific, that is called as 224.0.1.40. This is your address. This is the address on which the mapping packets will send once the election is being done. Okay. So now let's understand with the help of a diagram where we do have R1 over here, we do have, let's suppose R3 also, we do have R5 also. Over here, we do have R2, R4, and for example, R6. I have multiple routers which are in place. Let's connect them like this and like this also, and like this also. So we are forming up a table over here. Let's say my R1 is a RP or is a candidate of the RP. Okay. Over here, my R5 is also becoming the RP. What they gonna send? They gonna send what? The RP announcement packet. Correct? This is what I told. What is the address for that particular packet? 224.0.1.39. This is the packet they will send. To whom they gonna send? They only gonna send that particular packet to the directly connected routers. Okay. They're gonna send the packet to the directly connected routers, whichever they are having inside the network. So R5 has sent the packet to R3. R5 has sent the packet to R6. Similarly, R1 did over here, sending to R2 and R3. Okay. And that too, there is also a condition. When they are sending the packet, it is very important for the R6 that PIM has to be enabled at that moment. Similarly, over here also PIM has to be enabled. Similarly, on R3 also PIM has to be enabled. First condition, directly connected router. Second condition, PIM has to be enabled on those particular routers. Okay. Now in this, one of the routers will become the mapping agent. For example, my router R3, he becomes the mapping agent over here. Okay. Now this mapping agent will let everyone knows that who becomes the RP on which particular address, that is called as your RP mapping on 224.0.1.40. The message will go to all of the routers R1 and R5 and towards the R4 also, that who is the mapping. Okay. That I am having, these are the two RPs. I'm going to advertise the router R5, let's suppose, as a RP. So he became the winner. I'll just mark it in the red. This became the winner as per the election process, for example. Okay. Now R3 over here is the mapping agent in the network. It has received the announcement packet from R1 and R5. It has elected the router R5 as a RP, and that will be completely advertised to all of the network also, and that is called as your RP mapping packets. Okay. Now, how the election process becomes over here? When the two candidates who want to become the RP are belonging, or let's suppose for any of the group, which is 239.111, for example, they want to become the rendezvous point. My mapping agent will only prefer that router who has the highest IP address. This is the criteria for the election process. Again, I'm telling, what is the criteria? Highest IP address. Simple as that. This is the criteria for selecting up. R3 will advertise the mapping packets that gonna contain the winner R5 information and the group that he gonna serve. So my R5 became the packet, became the winner, and he want to serve on the address which is 239.1.1.1. This complete information will be sent to all the directly connected interfaces wherever the PIM is being enabled. So far, so good. No problem at all. R3 has sent this packet to R1 also, to R4 also, to R5 also. Now these routers have actually learned that which RP they can use. They have learned that my router R5 is serving on 239.1.1.1, and this is the RP, this is the winner where we want to reach it. But what about router R2? He didn't got the information, right? Because mapping agent is directly connected to R1, is directly connected to R5, is directly connected to R4. But my R2 is still remaining and my R6 is still remaining. They don't know that who is the RP right now. They will tell that I don't have any idea who is the RP. Now what happened? What do you think? What's gonna happen in that case? We forgot one thing, keeping in mind that we are using the PIM sparse mode over here. The multicast traffic is only forwarded whenever a router requests it with a PIM join message. And this PIM join message is being sent to the RP. My router R2 and R6 didn't receive the RP mapping packets. Reason being why? The reason is that router R1 and router R4 over here will never forward the multicast packets to 224.0.1.40. They will never forward this multicast traffic towards this. Okay. Or this mapping address will never be forwarded to router R2 and router R6. Okay. It will never be forwarded until and unless these gonna ask for that traffic using the PIM join message. Sparse mode we are using, right? So they're gonna send a PIM join message. My R2 will also send a request. My R6 will also send a request. And then the mapping will be done that, okay, you need to reach out towards R5, who is your router RP, in order to send the in order to accept the traffic for the multicast address 239.1.1.1. How they will get to know? They will get to know because of this RP mapping. And for that, they need to request it. And when they're gonna request it? Whenever they have a user who is sending the IGMP membership reports. Everyone clear? I tried my level best to make you understand this. From the scratch, IGMP, PIM, RP, mapping, announcement, election process, everything. Now you might having an idea that how other routers are sending the PIM join message towards the RP, because they will request based upon what they receive from their end host. And when they are requesting, there is a RP mapping IP, this multicast address, which will be going and telling them the complete information with that packet. There is a information about router R5 and he is managing about 239.1.1.1. This information will go whenever there is a request from other routers. Anderson, clear? Arvind, clear? Robin, sir? Tuan, Jabir, sir, clear? Yusuf, all good? Wonderful. So this is what we have as per your auto RP feature, where we're gonna make the election process. Okay. Tomorrow we'll understand certain things about your bootstrap, source specific, multicast bidirectional PIM, and normal PIM, and then we'll move ahead with the lab scenario of the multicast. Okay. So with that, we'll end for the day over here. Nice having a lecture. We'll meet you tomorrow, and till then, take care. See you. Bye bye. Have a great day, guys. Enjoy the night.